Welcome class to day number 2 of distance learning. Today we're going to be doing lesson 2, polygons and quadrilaterals. Just a reminder again, if I'm writing, you're writing just like in the regular classroom. You will be submitting, uploading all of your notes to me for your notes grades. And in response to yesterday was day number 1, we went live. So some feedback from yesterday. Know that when you comment on an assignment or if you turn in a private comment, we do not receive notifications for those comments. So the way that I see them is I have to go into the classroom, scroll down, and specifically look at all of the comments. This got a little out of hand. Some sections had over 100 plus comments, which I just cannot read through. People were treating it as if it were a group text, which it is not. This is a learning professional platform. Please only comment if you truly need help from your peers. Now, if you need help from a teacher, you must email us, call us, or text us directly using that Google Voice phone number that we provided with you and using our regular resurrection emails. Those are the only ways, or that's the best way that you can quickly and ensure that you get a response from me right away. So let's get started. So today we're going to be talking about polygons. Polygon is any closed figure that is made up of line segments. So we can think of lots of shapes. We have a rectangle is a closed figure made up of 4 line segments. Okay. We have a pentagon is an example of a polygon. What about a circle? Could a circle be a polygon? No, because it is not made up of line segments. Okay, you cannot have any curvy parts in polygons. A regular polygon has a little bit more specific. A regular polygon is a polygon that satisfies these 2 requirements. All sides must be congruent, and all the angles must be congruent. So we've studied a few regular polygons already. We studied a regular triangle, and we called him equilateral. Equilateral. Okay? All sides are the same. All the angles here are 60 degrees. We also have studied a regular quadrilateral. What is this called? That has all the sides are equal. And notice that all the angles are equal. This is a square, okay? And so you can continue on. So if all the sides are congruent and all the sides are, or all the angles are also congruent, then this is called equilateral and square. In this lesson, I'm going to be shorthand a lot that word congruent, so make sure that you remember that the equal sign with the squiggly on top means congruent in geometry. Furthermore, polygons can be convex if there's any 2 points that be connected with a line within the polygon. Okay? So I can do a few examples here. Look at this equilateral, right? If I draw a line from one point to another point at anywhere within my polygon, that line will be inside the polygon always. So it is a convex shape, okay? A square, again, if you draw a line anywhere within this square, the line will still be contained within that square. Let's look at an example where it would not. And the shapes do not have to be regular. So you can have something like this is a polygon. Okay. And as long as all the lines inside stay inside, then it is a convex polygon. An example of one that is concave, and a concave polygon is just any polygon that's not convex. So if I had a polygon, I'm making a bunch of straight lines here to make my shape here. Okay. This is a polygon. It's a shape that's made up of all straight lines. But notice here, if I go from this side to this side now, my line has gone outside of that polygon. Therefore, this shape here is convex. I remember it because convex, notice how all the sides go outwards, like you're flexing your muscles. And the concave, look, it's created a little cave where we can go and hide from the rain. Oh, okay. So convex, remember the shapes are flexing outward, showing all their muscles. Concave, we can go hide inside from the rain and protect ourselves. All right, some polygon names. We've studied particular polygons. Certain polygons have special names. So the ones that we're going to be concerned with is we're going to start with a polygon must have a minimum of 3 sides. and if it has 3 sides, what would we call that shape? If you say a triangle, you are correct. Okay. How about one with 4 sides? That is a quadrilateral. Quadrilateral. 5 sides is a pentagon.
Pentagon.
Pentagon. How about 6 sides? It's called a hexagon.
Hexagon.
Good job. 7 sides is called a heptagon.
Heptagon.
Heptagon. And 8 sides is called an octagon.
Octagon.
I know, that's your favorite.
Is this an octagon?
Let's do some examples. Is it a polygon? If so, is it convex or concave? Look at example A. Here we have a keyhole. Is this a polygon? Yes or no? If so, is it convex or concave? At this point in the video, I'm going to ask you to pause, answer A, B, C, and D, and then hit play to review your answers. A is not a polygon. Not a polygon. And it is not a polygon because if you look at the top of the keyhole, it has a rounded top. And polygons can only be made of all straight lines. Part B, the stop sign. The stop sign is a polygon. So yes, it is a polygon. We could classify it too by the number of sides. It has 1, 2, 3, 4, 5, 6, 7, 8 sides. And what's an 8-sided figure called? That has 8 sides?
Pelican.
A pelican. I think it's called an octagon. An octagon, yes. And this octagon here is convex. Convex. Okay. All the sides of the octagon are flexing outwards. Now, part C. Is part C a polygon? No, it is not a polygon. Notice the waves in the top and the bottom sides here. That is not a polygon. And part D, is this a polygon? The answer, yes, because it has all straight lines. It's made up of, it's a closed with made up of all straight lines. So yes, it is a polygon.
Polygon.
Okay. And is it convex or concave? It is concave. Concave. On the second half of this lesson, we're going to go into quadrilaterals. So if you are in my 8th grade pre-algebra class, this should look very familiar to you. We did this in our last unit, so it's going to be a little bit of a review for you today. Quadrilaterals are, we just learned, polygons that have 4 sides. And they don't necessarily have to always be parallel. So a quadrilateral could be something like this. It has 4 sides, 1, 2, 3, 4, made up of straight lines. This would be a quadrilateral shape. Now, the quadrilateral family, we're going to be talking about 2 branches of the quadrilateral family. It is either a trapezoid, if your quadrilateral has 1 pair of parallel sides. So I could draw a trapezoid here. Notice here that the top and the bottom are parallel. The left and the right sides are not parallel. So this would be called a trapezoid. Also in the trapezoid family, we could have a isosceles trapezoid. Okay, an isosceles trapezoid.
Mommy.
Yes?
I am a cereal.
Okay, please go be patient. Okay. 1 pair of opposite sides would make it an isosceles trapezoid. The left and the right are opposites, and the top and the bottom are parallel, okay? Making it an isosceles trapezoid. On the right-hand side, and the other family, it can either be in the trapezoid family, or we're going to be in what is called the parallelogram family. Parallelogram family. Okay, and the parallelograms must have opposite sides that are congruent and parallel. So a parallelogram could look something like this. Notice the top and the bottom are parallel, the left and the right are parallel. The top is also the same size as the bottom, and the left is the same size as the right. This here is a parallelogram. Now a parallelogram can have two more restrictions. It could have all four sides that are congruent, in which case this would be a rhombus. This would be a rhombus. So this would be a parallelogram where the top, left, right, bottom are all congruent. Okay. Or it could have four right angles, which would make it a rectangle. Okay. Here. So the top and the bottom are parallel. They are congruent, left and right parallel congruent, and it is made up of four right angles. Remember, right angles is 90 degrees. Okay. And then the last one at the bottom, if it is both a rhombus and a rectangle, meaning that it has four congruent sides and it has four right angles, then it is a square. Okay. So here's a square. All four sides are congruent and it has right angles. Now I give you some further hints. Those of you who might remember them. If I'm going downwards, so I could ask you, is a trapezoid always, sometimes, or never an isosceles trapezoid? And the answer is, well, a trapezoid can sometimes be an isosceles trapezoid if it has one pair of opposite congruent sides. So as you move down the chart, where should we put this here? As you move down the chart, okay, then they are sometimes the same. And they're only the same if they satisfy those additional requirements that we need to move down the chart. Okay? As you move up the chart, though, the answer is that they are always the same. So if I look at the square, is the square sometimes, always, or never a rhombus? Well, does the square have all four congruent sides? Yes. Therefore, it is always a rhombus. And a rhombus is always a parallelogram because it always has opposite sides that are congruent and that are parallel. And a parallelogram is always a quadrilateral. Okay? And however, though, from left to right, that answer would be never. Okay? A trapezoid can never be a parallelogram, and a parallelogram, anything in the parallelogram, can never be a trapezoid. Okay? Because in order to be a parallelogram, you have to have two pairs of parallel sides. In order to be a trapezoid, you only need one pair of parallel sides. Okay. Let's look at these examples where we're going to classify the quadrilaterals. In part A, notice how the top and the bottom are opposite sides. They are parallel, indicated by the two arrows pointing the same direction, and they are congruent. Notice by the two slash marks on the top and the bottom, indicating that they're congruent. The left and the right are also congruent and parallel, indicated by one arrow and one slash mark each. So what would this shape be called? The answer is that this is a parallelogram. This is a parallelogram, would be the most specific name for this shape here. Okay, you could say it is a quadrilateral, yes, but we want the most specific or the best name for each of these shapes. So the best name here is a parallelogram. Look at part B. What would you call this shape? If you answered a rectangle, then you would be correct. Okay. Notice that it has all four 90-degree angles. If it's 90-degree angles, we know that the top and the bottom, or the left and the right here, are perpendicular. So I know that the top here is going to be parallel to the bottom, and the left and the right will also be parallel. Okay. However, I do not know the lengths of the sides. So although some of you may have thought, well, Miss Ayers, why is this not a square? And the answer is because we don't know the lengths of those sides around here. This could be 6, this could be 5.8. It could look very similar, however, not be the same. So the most that we can say about this shape is that it is a rectangle. Okay. And for the last part of our lesson, we're going to be talking about the angle sum theorem of a quadrilateral. So the sum of all the interior angles, remember that word interior means inside, so the four inside angles of a quadrilateral is equal to 360 degrees. Yesterday, we talked about how the three angles within a triangle are 180 degrees. So let's answer this question, why? Well, are quadrilaterals related to triangles? And the answer is yes. You can draw a line within any quadrilateral that would split it up into two triangles, 1 and 2. I can do this here, 1 triangle, 2 triangles. Even on an irregular polygon or irregular quadrilateral here, if I extended this top part here, I'd have one little baby triangle and a big triangle down at the bottom. And we know from yesterday that the angles of a triangle are 180 degrees. And so if I have 2 triangles that make up my quadrilateral, I'll just use a rectangle to represent the quadrilateral family, then 180 plus 180 is going to be 360 degrees. Okay? So that's the theory behind this theorem. Let's do an example. Let's find all the angle measures given this figure here, given this quadrilateral. So remember, the sum needs to be 360. What does sum mean? It means to add. So let's add all of our angle measures. I'm given this top angle here to be 68, plus, look at this bottom one here. Remember that a little square indicates to you a right angle, and a right angle is 90 degrees. So I have 68 plus 90. Moving on, we have the next angle here is 2x plus 1. And the fourth angle here is x. So we can add x. And all 4 of these angles must add up to be 360 degrees. Okay? So our first step here is going to be to solve for x. We are expert equation solvers. I know you all are. So we need to start by combining our variables. So I have 2x plus x, which would leave me with 3x, plus, now combine your all your numbers, 68 plus 90 plus 1. Okay, so 91 plus 68, I believe that should be a 159. Double check my math here. Yes, I am correct. 3x plus 159 is equal to 360. Okay. In order to start solving for x, I'm going to use inverse operations, subtract 159 from both sides. 159 minus 159 is 0. 3x is now equal to 360 minus 159, which would leave you with 201. Divide by 3, and x is now equal to 67 degrees. I'm sorry, 67. Okay. Now we need to find, though, all the angle measures. That's what the question is asking for. So let's start at the beginning. We started with the first angle, which is 68. So angle number 1 we said is 68 degrees. Boom, done. Angle 2 we said was represented with this square, and the square represents that it is a right angle, which is 90 degrees. Awesome, halfway there. The third angle we said is going to be 2x plus 1, but what did we just say x was? X is equal to 67. So plug in 67, 2 times 67 plus 1. Okay. Well, 2 times 67 is going to be 134, plus 1 is 135 degrees. And our last angle up here is x, and we already know x here is 67, so the last angle is 67 degrees. Therefore, the angle measures for this quadrilateral are 68, 90, 135, and 67. Okay? So your homework is on the website already. My advice for the homework is open up that PDF document. That is where you will find the textbook problems. Then complete all the problems on your worksheet. If you need help with them, reach out to me via email or the Google Voice number. I do receive those on my phone as text messages and phone calls. The email also goes to my phone, so that's the best way to get a hold of me as quickly as possible. And also, don't procrastinate till late in the evening. We will be responding always between 8 and 4, but after 4 o'clock, the teachers, we have to take care of our families as well. So we may get back to you after those hours, just not as quickly as between 8 and 4. And then once you have the entire assignment complete, then I would go to the assessment's website and upload your answers. If it is an open-ended question, I got this question yesterday a few times, then it will prompt you to submit a picture of your work. So for example, if I were to ask you to draw your own quadrilateral and classify it, then you could do that on your sheet of paper, upload it as a picture or as a file attachment on the assessments website, and that's how I can see it. So again, if you have any questions, please reach out. Day number 2 down in the books.